Picture this. An entire universe smaller than an atom, then bang! The Big Bang unleashes everything: space, time, matter, energy. The universe inflates rapidly, a cosmic fireworks display. It's a chaotic soup of particles colliding at unimaginable speeds. Over eons, the universe cools and expands. Particles clump together, drawn by gravity's irresistible pull. These clumps become the first stars, massive furnaces that ignite, flooding the universe with light. Inside these stellar cores, hydrogen fuses into helium, forging heavier elements, the building blocks of planets, of life itself. These early stars live fast and die young, exploding as supernovas. These cosmic explosions scatter newly formed elements far and wide, seeding the universe with the ingredients for future generations of stars and planets. Our own sun is a late bloomer, forming billions of years after the Big Bang. It ignites within a swirling cloud of gas and dust, a nebula enriched by the remnants of countless dead stars. This swirling cloud, our solar nebula, holds within it the seeds of our planet and everything we know. It's a humbling thought to realize that we are all made of star stuff. Within the solar nebula, a slow dance begins. Microscopic dust grains, remnants of ancient stars, collide and stick together. These tiny particles, drawn by electrostatic forces, begin to clump, forming larger and larger aggregates. Over thousands of years, these clumps grow from dust grains to pebbles, then boulders, and eventually planetesimals, the building blocks of planets. Imagine a cosmic game of marbles, but on a grand scale. Planetesimals, drawn by gravity, pull each other into chaotic orbits, colliding and merging. Some are flung out of the solar system entirely, lost to the vastness of space. Others remain trapped in the sun's gravitational pull, destined to become planets. In the inner solar system, where temperatures are higher, only rocky materials can withstand the heat. Here, planetesimals composed of iron, nickel, and silicates collide and coalesce, gradually forming the terrestrial planets: Mercury, Venus, Earth, and Mars. Further out, beyond the frost line, ices and volatile compounds survive, allowing gas giants like Jupiter and Saturn to form around massive cores. The early Earth was a hellscape, a molten ball of rock and metal bombarded by asteroids and comets. The energy from these impacts, combined with the heat generated by radioactive decay within Earth's interior, kept the planet in a molten state. Imagine volcanoes erupting on a global scale, spewing lava and gases into the primordial atmosphere. As Earth cooled slightly, a thin crust began to form on its surface, constantly broken and reformed by volcanic eruptions and asteroid impacts. The heavier elements, like iron and nickel, sank towards the center of the planet, forming Earth's core. Lighter elements, like silicon and oxygen, rose to the surface, forming the mantle and crust. This process, known as differentiation, shaped Earth's internal structure, creating the layers we know today. The early atmosphere was a toxic mix of gases: carbon dioxide, nitrogen, water vapor, and methane, spewed from volcanoes and delivered by cometary impacts. There was no free oxygen, no ozone layer to shield the surface from the sun's deadly ultraviolet radiation. Life, as we know it, could not have survived on this early Earth. Section 4. Shaping a World, Impacts Air and Water. The bombardment wasn't all bad, you know. Comets and asteroids, remnants from the solar system's formation, delivered more than just destruction. Locked within their icy depths were water molecules, the essential ingredient for life as we know it. Over millions of years, these icy messengers crashed onto the young Earth, depositing their precious cargo. As Earth cooled and the bombardment subsided, water vapor in the atmosphere condensed and fell as rain, forming the first oceans. These early oceans were acidic and hot, but they provided a cradle for the first life forms to emerge. Meanwhile, volcanic outgassing continued to release gases into the atmosphere, shaping its composition. Photosynthetic bacteria, the first life forms to evolve on Earth, played a crucial role in transforming the atmosphere. They absorbed carbon dioxide and released oxygen as a byproduct of photosynthesis. Over billions of years, this process gradually increased the concentration of oxygen in the atmosphere, paving the way for the evolution of oxygen-breathing life forms. Section 5. Our celestial dance partner, a moon is born. Earth's early history is a tale of violence and change. Perhaps the most dramatic event was the formation of our moon. The giant impact hypothesis suggests that a Mars-sized object, named Theia, collided with the young Earth. The debris from this cataclysmic collision ejected into space eventually coalesced to form our moon. The impact had profound consequences for Earth. It tilted Earth's axis, giving us our seasons. It stripped away much of Earth's early atmosphere. And it created a system of tides driven by the gravitational pull of the moon, which may have played a role in the origin of life. Our moon is more than just a celestial neighbor. It's a time capsule, preserving a record of the early solar system. Its cratered surface tells a tale of intense bombardment, a reminder of the chaotic conditions that prevailed during Earth's infancy, and its presence stabilizes Earth's rotation, preventing extreme climate swings that could have made life impossible. Section 6. Reflections on a speck of dust. From a cosmic perspective, Earth is but a speck of dust orbiting an average star in a vast and ancient universe. Yet on this tiny planet, life emerged and evolved, eventually giving rise to us beings capable of contemplating our own origins and the grand cosmic drama that unfolded over billions of years. Understanding Earth's formation journey allows us to appreciate the fragility and preciousness of our planet. It highlights the unique set of circumstances that led to the emergence of life on Earth. And it fuels our curiosity to explore other planets, to search for signs of life beyond our own, and to unravel the mysteries of the universe we inhabit. As we continue to explore space, we carry with us the knowledge of our planet's epic formation journey, a story written in the stars, the rocks, and the very molecules that make up our bodies. It's a story that reminds us of our profound connection to the cosmos, a story that continues to unfold with every new discovery we make.